Okay, so I've tried to do this intro like 4 times, and starting the video is always the hardest part, so we're just gonna get right into it. Okay, welcome back. The video I just uploaded, which is a lock bar video, and by the time I upload this one, that's probably not even gonna be relevant anymore. But that was like 3 weeks ago, and so a lot of things have changed since then as far as like the knife goes. So we'll talk about that. But just as a quick aside, if you follow me on Instagram, you know that I've been working on this samurai project, and I think I talked about it. Actually, I didn't talk about it in the other video, but I just wanted to show off the flatbed that I did for it. I'm not really going to do a video on the samurai stuff because obviously it has nothing to do with knife building or machining, but I'm pretty proud of the flatbed myself, so yeah, I gotta show somebody, I guess. So here she is. It's beautiful. It's 5 feet long. That's pretty long for a samurai flatbed. You know, they didn't come from the factory with truck beds on them, so yeah, I raptor lined it. U-Pole makes it. Pretty good product. I've never used it before, and I really like it. It's polyurethane, I think, rubberized texture, and the only downside is how long it takes to dry, like to working time. Actually, I mean, everything takes a long time to dry, so I painted this yesterday morning, or sprayed it on yesterday morning, and it's drying. It's 5 to 7 days depending on the heat, the weather outside, and yeah, so that's pretty much it. It's got a nice internal box, lots of E-track rail, and the cool fuel filler neck, which took me forever to make, but that's what it looks like. So yeah, a quick note about flatbeds is whenever I see cool flatbeds, they're cool and all, but their usefulness is about a zero. Actually, that's the OK symbol, a zero. Is this a zero? Their usefulness is low because they end up doing a deck like this and no box, nothing, no way to secure anything, so they look cool, but they end up being absolutely useless and really just a pain to put anything on. So I kind of went all out, did the E-track. So the E-track uses these quick disconnect type things, and they work really good. Actually, those are rated for a working load of 1,100 pounds, and I believe it because I've actually lifted this thing up with the engine hoist with those attached to 2 points. I don't recommend doing that. And yeah, that's pretty much all I'm going to talk about that thing. A quick little tangent. I did quite a bit of cleaning in here last day or two. It's obviously still not perfect, but I've decided to use this table as like a processing table. So we got a little heat treat oven here now. It's a 120 volt, but it will go to 2000 degrees, so it should work for what we need it. It's slow, but that's what I got for now because I can't buy an even heat because I'm poor. Got some 309 wrap from USA Knife Maker. It's the stuff you need to wrap stainless blades in for heat treating so they don't get oxidized. Got a little arbor press. We're gonna make some aluminum plates for it. That'll be, they go in here. When they're done, they go in there to get quenched, like quenched on plates. So that's cool. That's kind of where I'm at with that. Over on the machine, we got 2 of the newest handles done. These are correct. And then, let's see, we'll talk about what I currently have. The office is kind of a mess, but... so this is currently what the new knife looks like. That's the, this is obviously a rough sketch, if you will. But that's, yeah, completely different blade shape, obviously. But yeah, that's kind of where we're at. And yeah, so right now I am working on the fixture, the blade fixture for the newer style, plus hard milling. So this blade was soft milled, if you will, so no heat treating. And you can see that the finish is good as far as like finishes go, kind of. The lines are from it walking on a clamp, but it's not terrible really, and it matches pretty good in the fixture. But I know hard milling is like kind of the way to do it. So what I'm doing is I'm basically making the tabs from op 1 follow through. So what we'll do is we'll do the rough out, kind of rough the blade shape out, and then you take that roughed out profile with the tabs and we'll heat treat that, and then we'll basically hard mill every feature on here, including the pivot, because when you heat treat, I guess the your pivot dimension will change, and we obviously don't want to lose the pivot dimension before actually assembling the thing. So yeah, that's kind of the game plan. So like I said, we're gonna cut a raw one out, and then we'll fumble around with the oven and go from there. Before we start the blade part, here's the newest set of handles off the machine. I thought I'd talk about them and some issues we had, of course. So first, right off the bat, that I did not see yesterday, which is sorely disappointing, but the lock bar insert has this tapped hole right here where my pinky is, and obviously there is not a whole lot of space for a standard piece of hardware. It's very narrow kind of thing. So unfortunately, getting the tapped depth at the borehole is really difficult, so apparently I didn't get it 100% correct. So if you look, see it kind of poke through when the ball end mill came into the outside contour. So we'll have to work on that, but the threads in the hole look good. I also worked on the chamfering, everything. So everything looks really nice on the inside, chamfer-wise. I tried to do a engraving. If you keep going out of focus, I'm going to kill you. And you can see that it says, what does it say? Text test, prototype, and then prototype actually fades away. So this led me to investigate why that might be a thing, and the fixture is off by 3 thou, so it actually like dips down at that side. So that tells me the fixture needs to be remade, which sucks, but that's that was inevitably going to happen anyways, because I was going to make it out of chromoly, because aluminum is for prototyping and it has served us very well, obviously. Let's see, the other topside handle came out very nice. So there's the inside, very good. Here's the outside. The pivot shoulder has gotten bigger, a more flatter area, and I just figure having the pivot a little more captive and a bigger shoulder will be better strength-wise long run. So that's pretty much it as far as handles go. Luckily these are still very usable as far as like testing goes, so they're not scrap. I mean, they're not sellable, but they are, you know, prototypes. So now all we need to do is we're going to take our blade fixture, which is this guy, and we need to cut 2 pockets in here and here, that way we can fit the tabs from op 1, and like I said, heat treat and then hard mill them. So yeah, let's do that. I think the reason that the handle fixture is off by a couple thou is because, well actually, I think it's because of this. See that mark right there? Let's see if you can see that. Right in the middle between those 2 dowels, right there. Strangely looks like a bolt head and the threads, doesn't it? Well, that's my guess as to where our fixture wonkiness is coming from, because on this backside handle op thing, these bolts stick in here, and I forgot to take them out, and sometimes what happens is they fall down, so you go to put the plate down and then you start to tighten it. Well, if one of those had fallen down, you wouldn't notice it until you tightened it down, and then of course it was risen up. And I mean, those 1/4-20 bolts put a lot of down pressure on the thing, so obviously it smushed one of the bolts in there. Before I noticed, the only reason I noticed is because it was cut in this weird groove, and I was like, that thing's not sitting flat. So yeah, that's big mistakes lead to problems down the road kind of thing. So yeah, okay, I got the Oh, you know, I was thinking, if you took a drink every time I said "so yeah," you'd be very hammered before the before the video got to the halfway point. Anyways, enough tangents. So this is the blade fixture. G55 is set off this corner, precision machine corner, if you will. So we know that's good when we set the G55 there. And yeah, so let's cut these pockets. Alright, cool. I just set the machine up and we're gonna go ahead and do this adaptive. I have to kind of ramp the machine down and then bring the spindle up to speed, because if I don't, my machine actually shuts off from some voltage issues I have, and yeah, we won't go into it. Alright, I'm curious to see if this worked, because one of the pockets on the side, or the tap holes on the side, were pretty on the side. I think that'll work. This is what I'm talking about, it's like really close to the edge. Cool. I think that'll actually do what we want. Cool. Alright, let's see if we can figure out this roughing out strategy now for the blade. Okay, we got our piece of raw material, 4-inch piece of S45 VN. We're gonna slap her down in the machine here, but make sure your junk is not covered in chips, so she remains nice and flat. And by junk I mean the parallels. Oh no, that's not what I wanted to do. That's how you put a dent in your table. Yes. Okay, not bad. As I was saying, don't put dents in your table, it's not good. So you got our raw material, then you just hit the go button and go. I'm just kidding. Tighten her up. Okay, cool. Give her a little snugness. That's actually not the side I wanted to be on, because I filed this side. Make sure you deburr the edges when you want this to sit flat. And I just put a little bit of pressure down, nothing crazy. Then I take a rubber mallet. I guess the mallet is rubber. Tap. Sometimes you can hear it when it seats. And then the way I have this programmed right now is G54 is located somewhere in that vise. But if you use Fusion's probing routines, we can actually just set G54 adjust G54 from the last known G54 position. So that's what it's going to do. Always scares me when the probe flies to the part. But it's basically going to, based on the last G54 I had, it's going to then update the G54 based on the center of the part. So you basically tell it to go to its certain travels, and it'll over travel and do all that. And it'll just, like I said, reset G54 to the center of that part, so we're always good. So I don't always have to probe it, as long as G54 was close to what this G54 needs to be for the next job. And the Z height doesn't change because it's the top of the parallels. So yeah, so it's good. Come in here and face this thing. Get very close to the parallels. And I need to come up with a new way to do this, because this isn't the best. There's definitely some chatter. So I'll come up with something for the next kind of iteration of all this. Yeah, it's pretty painful. And we're basically just going to drill, spot drill, and then contour out for the 1/4 20 hold down holes. Definitely could speed up some of this process for sure. But it works for now. It's better to have it work and be slow than be fast and not work very good. Oh yeah, it's doing its tool breakage. Okay, cool. It's tool breakage, and so what we're left with is the 2 hold down holes, and they get located right there. So we're going to take that, put that on there, rough it out, and then we'll take it off, and then we'll heat treat it. Okay, oven's warming up. It's a 120 volt, so to get to 2000 degrees it takes an absolutely astronomical amount of time, but that's working. And I got our piece set up, bolted down, so we're going to go ahead and rough that out, and then we'll burn it. So we're ready to fire this up. I made sure to turn off machine shallow areas, otherwise it would want to step into the actual bevel. So this will keep the tool just on the outside profile of it. So that should be good. I'm leaving 20 thou radially, and I think that'll be enough in case it grows. That should give us plenty of room for contouring and all that on the hard milling side. So I'm using a 3/8 4 flute, pretty stubbed. Oh, that's weird. Oh, I must have it flipped the wrong way. I was wondering why I cut immediately. Hold on, let me flip it. That's why they do that pokey-okey thing where you can't flip things on backwards, but usually I had that 3/16 hole from doing the soft milling, and so that's why I got it backwards. But here it is on the right, and yeah, I'm glad we caught it, because otherwise that'd have been a whole waste of this 45 VN, and this stuff's not cheap. Alright, roughing done. Took 8 minutes. Nice clean profile we got there. So pull it off. Put a new band-aid on for my awesome cut I have. That's a huge cut. It's more like a lopping off of my... I won't get into it. I'm not sure why, but I always like the look of like the roughed out profile. I don't know, there's something about it, you know? Well, I mean, minus that part. But yeah. Whoa. Okay. We need to learn how to wrap these things now, because if you wrap them incorrectly, then oxygen gets to the blade, and if oxygen gets to this type of stainless, the heat treat's pretty much no good. So yeah, let's fumble around with this roll of 309, but first let me kind of deburr this thing. I get it kind of deburred. I think that's a symptom of the end mill being dull. So I am not entirely sure how to do this, but we will learn together. We will fail together. I hear this stuff is extremely sharp, so I'm all about cutting myself, so I'm sure that'll happen. Maybe we'll go put gloves on. It looks sharp. Okay, so this stuff is very thin, obviously. This is new territory for me, obviously. I don't know where my metal shears are. That would have been really helpful. It's kind of annoying. Okay, that's fine. We'll use these side cutters. So I think what I want to do is obviously have like a nice amount of stainless to be able to do the thing. So I'm just gonna kind of draw a nice square. Sure. Alright, I'm gonna go find my shears because those are not gonna work. These are shears, right? Let's see if this works. Oh, this works really good. I should just be using scissors from now on. Alright, cue the part right. I'm pretty sure most people fold over to the front and like roll it over, so maybe that's what we'll do. We'll like do this, and then we'll kind of... Okay, yeah, see how this might work. So we'll do this. Man, I've been gone for like 15 minutes, and the oven's only at 1500 degrees. That's slow. Okay, as I was doing, what was I debating? Oh yeah, corner. Well, I think we should do the sides now. I think. I guess we'll do like a tight wrap on the side first, like this. Oh, you know what? I forgot baby powder. I heard that's a thing. So they don't stick. Huh. I'll be back. No baby powder to be found in the wife's supplies, so we're going in dry. I think that means the blade's gonna kind of stick pretty hard to the packaging, or the foil. So guess that's just something we'll kind of have to deal with when we get there, which will be in hopefully an hour. Oh no. See, if you've never done this before, and you watch somebody do it who's like done it a bunch of times, it looks really easy. But then you step in there and do it, and you ain't got a clue what's going on, like I currently look like. Obviously you want to be careful not to... Okay, I think this is my best attempt at it. I'm not entirely sure how it could get any better. I mean, this is obviously the best piece of work I've ever done. Blade burrito. So, I actually ran out of time. It's kind of late, and the oven just hit 2000, so it's going to take like another hour and a half to do this whole heat treating thing. And I don't want to stand around and wait. And I'd like to get this video out, like, you know, tomorrow, and try to do like quicker rotations of videos, kind of more vlog style, I guess. It's easier on the brain, you know what I'm saying? So yeah. In the meantime, I was sanding some handles because we're gonna practice anodizing them at some point. But yeah, that's all from me. Congratulations to myself, 500 subscribers. I'm kind of a big deal now. I'm just kidding. Thanks for subbing. And if you like this kind of content and you haven't subbed, you probably should. And yeah, enjoy your week.